In this video, we're going to talk about how we make a decision on whether we reject or fail to reject the null hypothesis depending on the p-value, and we're going to relate how that makes sense to what we already know about the rejection region method. So when you have a p-value, you're running a hypothesis test. Remember, you have a level of significance. You have an alpha value. We need to compare our p-value with that level of significance alpha. So let's take a look at what we already know. Let's say that I have some bell curve. And let's say that this is before we learned about p-values and we had gone in and we found the critical value. Let's say we have a left tail test and we find a critical value. That's some z sub c. That critical value, if this is a left tail test, I would be shading to the left. And that would give me my rejection region. And that total area that's shaded in black there is alpha, right? Or that level of significance for this left tail test. Now let's say that we come in and we drop in our test statistic, and let's say that our test statistic had landed right here. What we have learned for a left tail test, what we just saw up here, remember this red test statistic that I just dropped right here is the same red test statistic that I dropped up there. So what we saw up there is that the p-value is this area here. So remember, what's shaded in black is alpha, the level of significance. All of this, it went away. All of this in black, that's alpha. And then all of this in red is the p-value. That red area is the p-value. Well, let's see. Well, if that p-value, that red area, is less than alpha, which it is in this picture because there is less red shading than there is black shading, then the test statistic is in the rejection region. So if the p-value is smaller than alpha, the level of significance, then we should reject the null hypothesis, because that means that the test statistic, which is what this red thing is right here, fell into the rejection region. So it's another way to look at, to still think about rejection regions, but we don't have to actually go in and find what this critical value is, right? Because we're not comparing the critical value to the test statistic. We're comparing the area of the test statistic to the area of the critical value. So let's see what would happen in order for us to fail to reject. So I'm still going to consider that I'm doing a left tail test. I'll still have my critical value right here. So I'm shading the area to the left of that to give me my rejection region. But let's then say that the test statistic came and it fell in right here. Let's say that that is the test statistic. What we learned before is that in this scenario, this is the test statistic right here. In this scenario, we would fail to reject the null hypothesis because that is not in the rejection region that's shaded in black. But what we have learned in this lesson so far is that the p-value in this scenario, because this is a left tail test, I'm shading to the left of my test statistic. All of that blue area is the p-value. And we can see that that blue area of the p-value is greater than the level of significance alpha, because remember, the level of significance alpha here depended on the critical value. That's just what's shaded in black there. So when this happens, we will fail to reject the null hypothesis. So the p-value method does not compare the test statistic to the critical value like the rejection region method does. It compares the area of the test statistic, which is the p-value, to the area of the level of significance, which is our alpha value. So let's see how that changes the steps that we follow. So when we're using the p-value method, we do not set up a rejection region. I want to emphasize that. So if I were doing this, I wouldn't actually have labeled this critical value. I just erased those z sub c's that I had there because I wouldn't need to go look up those critical values in the table. We don't need those critical, yikes. We don't need those critical values, We don't need those critical values because we already know the area. We were given the area from the start. It's alpha, the level of significance. So we just make that decision by comparing alpha to the value of p. So steps 3 and 4 are just a little bit different. We still do step 1, we write our null and alternative hypotheses. We still do step 2, where we calculate the test statistic. Generally speaking, with hypothesis testing, if you're using a calculator, if you're using a paper, if you're using StatCrunch, step 2 is where you need to be particularly careful, because the formula, if you're using a paper, or the procedure, if you're using a calculator or StatCrunch, right, like the button that you would actually click on, is going to vary depending on the type of hypothesis test that you're doing. So far we've seen 3 types: mean, where sigma is known; mean, where sigma is unknown; and a proportion. And we'll see more examples of more different types of hypothesis tests too later in the course. So step 3 is a little bit different, because once you have your test statistic, you calculate or you find your p-value. And how you find your p-value is going to depend on which tail test you're doing. And you need to look at your alternative hypothesis for that. So what I mean by that is your p-value is going to be one of these 3 scenarios up here, whether it's a left tail test, a right tail test, or a 2-tail test. So you need to be using, keep that in mind. So I'll just wonder if I can, so like when y'all are looking at your entire paper, I'm drawing an arrow from this to up here, okay? Because what I mean by that is which tail you look at depends on HA. Your p-value could be in a very different place depending on what type of test you're doing, which tail test you're doing. Once you know what your p-value is, you will then make a decision on whether you're going to reject or fail to reject HO, and that decision depends entirely on which one is bigger. So I'm just writing exactly what we talked about up here in red and blue. If your p-value is less than alpha, you reject HO. But if your p-value is bigger than alpha, you fail to reject the null hypothesis. So those are the only 2 steps, step 3 and 4, that are a little bit different. Step 5, we still make our conclusion depending on what decision we made in step 4. And now let's go look at some examples where we do hypothesis testing using the p-value method.